All right, here we go. This is the third day, the last day for section 6.1, the area between two graphs, okay? Or the area of a region, as it should be called, because you could have more than two graphs. Oh, FYI, I have talked to Mr. Barber. I am going to try to outfit my room for Skype by the end of the year.
That is awesome.
That will be. No.
That'd be sweet.
That would be the coolest thing.
Where are you going to do it from?
Next door first. Yep.
So I was at Rose Holman.
Yeah.
In their classroom, and they had the 3 whiteboard combo, the 3 projectors, and the back whiteboard. It's awesome.
Nice. See, I need that. I can either take a pay raise or take that, so I think I might just take that. And
Why wouldn't you take
because it's not going to be very big. I can get more in tech money than I can in actual spending money. Go figure that. I think I'll just set this up with dy because on the quiz, you're going to be setting them up. I think I'll go dy, and I think today we'll talk about how to do a parametric plot. Okay? A parametric plot. Yep. A parametric plot means I'm going to introduce, kind of like in integrating, you introduce U substitution to make the problem easier to read and solve. Okay? I'm going to introduce T substitution for parametric plotting. The T stands for time, used a lot in physics. This way I can write both equations using T. The reason is, if you are in parametric plots, you can graph out things that aren't functions, okay? It's going to come in very handy as we keep going in this textbook, parametric plot. I've had several people ask, does it get easier? And no, it doesn't. So this is important because of later on. Anyway, to do this, you have to understand how it works. We kind of did a little bit last year in polar graphing. Do you remember we had like the theta and the theta step, and we made the roses and the petals and things like that? It's along that same line. You're converting the equation from algebra to parametric mode. And in number 30, I'm going to let y equal t. Okay? If y equals t, that means x will equal t squared. Okay? Now, for every graph of x, for every graph you need 2 parametric plots. Okay? 2 parametric plots. And the reason I let y equals t is, well, if I let x equals t, then I'm back to where I was having a problem with the t squared. So always pick whatever is squared or whatever the problem is. Some people like this style of graphing so much they never go back to the other way. They always keep it in parametric. I don't. I don't like it because of the 2 graphs you have to have, or 2 equations for each graph. So, how you doing, Joey? Thank you. All right. So for the second one, I'm going to do y equals t. That means x will equal 2t squared minus 4. Okay? Now, when you introduce a third variable, that means you have 3 sets of mins and maxes to worry about. I keep them all the same, -10 to 10, unless I need to start changing one or the other. That's the easiest way to explain it, is they should all run the same way. Since you're just starting out, you're not sure what does what. So, all my mins and maxes for x, y, and t will be -10 to 10. You'll be introduced to something called a t-step. That's kind of like the theta step. The smaller you make it, the more points you're generating, the better accuracy you get, but also the longer it takes to graph. I think I'll start out with a 10th and see what happens. Okay? So, it's kind of exciting, it's kind of fun, and I'm looking forward to it, so let's get after it. Anyway, I do this anytime there's non-functions. I go to mode, and I change it from function to parametric. First of all, you'll notice when you go to parametric, you see that xt theta n button? Watch very carefully. Watch. See the x is first? That stands for function. What comes second? T. That stands for parametric. What comes third? theta. That stands for polar. And the N, sequences. Okay? So that's why the buttons are set up the way they are, because if you're in parametric mode and you hit that button, you're going to get a T. If you're in polar mode and hit that button, you're going to get a theta. So far, so good? Fantastic. Next, to the cloud, actually to the window. Negative 10 to 10. Negative 10. I can't wait to Skype and say that. Negative 10 to 10. Step of 0.1. Minimum. Why do you pick? Not because you're new at this and you have no idea how this works. And I'll pick 1 for my scale. It doesn't matter. Negative 10. You also lose some of your graph calculate options with this. That's kind of a bummer. But we'll get to that later. Okay? So, negative 10 to 10, negative 10 to 10, 1. What's wrong? What's wrong? All right. Scroll down. What's the problem? Negative 10 to 10, negative 10 to 10, negative 10 to 10. Okay? So y equals, my first one. See, when you clear it, I'm going to let x equals t squared. And then y is going to equal t. Now, both parentheses turned on, that means you're ready to go. Clear this one out. X wants to be 2t squared minus 4. And then y is going to be t. As a standard rule of thumb, when you start switching your windows to see things better, it's always the best to keep your t's and x's the same. Okay? That's always a good rule of thumb. I would keep them all the same, but some people always like to, go on their own. Graph. See, it looks the same. There we go. Now, the question is, which one do you think is which? Which parabola do you think is the one on the left? Which one do you think is the one on the right? Hi. Yeah. Zach?
Signature.
All right, ready? So which one's which?
The one on the left is the -4.
I agree. The one on the left is the -4. How do you know that? We'll put 0 in for t and see what you get. You get 0 for one, -4 for the other one. So this is 0, -4, and this graph is 2y squared minus 4. This graph right here is just plain y squared. Okay? So far, so good? Next, you have to find these intersection points. And we said the easiest way to do that is just to set the graphs equal to each other and solve. Y squared equals 2y squared minus 4. 0 equals y squared, 2y squared minus, oh, it's going to be y squared. I got thrown off by game there for a little bit. I got distracted. So 0 equals y squared minus 4. So y is going to equal plus or minus 2. Okay? So this is going to be at 2, and this is going to be at -2. So there's my bounds. There's my integral. And remember we said whenever you're working on the vertical or the horizontal rectangle, we like to do right minus left to keep it positive because of the nature of the positive and negative regions of the y-axis. So I'm going to go from -2 to 2 of y squared, 2y squared minus 4 minus y squared. Does anybody think that that's symmetric? -2 to 2. Do you think it's the same region above and below the x-axis?
Yeah.
Okay. The reason I'm saying this is when your student solutions come out, you might see shortcuts, and you'll only see one change instead of both changes. Next week, you'll start seeing this. 2 times 0 to 2 of 2y squared minus 4 minus y squared dy. Oh yeah, it should be right minus left, sorry. I got all concerned about the -2 and 2. Good, that's why it's pencil. Anyway, my race is pretty good actually. Y squared minus 2y squared plus 4 y squared minus 2y squared plus 4. So when you're doing that, you see how they doubled the area from 0 to 2? Instead of calculating the area from -2 to 2. You'll start seeing that. If you see a 2, check the bounds right away. They're doubling something that's very symmetric. Okay? It's like making a heart cutout. You know how you fold it over, make the heart, and you open it up? Well, it has the same volume if you double or if you open it up and add it all together. That's what they're doing here. So, are we supposed to find the answer or just set it up? Okay. Anyway, I want to go through parametric plotting. And somebody goes, well, how do you do it? You know, since you can't do the y1, the y2 on the function integrate since you don't have it. Oh, easy. If you had to do it, second quick, you go to math 9, and I would type out 2 math 9 negative, I would simplify it a little bit, negative t squared plus 4 comma t comma 0 comma 2. You can use any variable you like. You can go back to function mode and put x's in if you want. But you don't have to always call up the graph to do so. Okay? Because you're not going to be able to put parametric plots into there like we have been doing. So you can use whatever button comes up. If x's come up and you want to type it in, it's fine. So you're not referencing it in any way. And it's 10 2/3. Okay? Yep. Oh, because you see how this equation, you could solve for x equals y squared and x equals 2y squared. You could easily isolate y. Well, starting next week, they're going to put another one there, forcing you to do it dy, and then that way you can't graph that under y equals. All right? So this is a nice example to show you how to do a parametric plot. And later on, parametric plot will be the only. I've seen kids take their graph screens, turn them, try to switch x's and y's, but then you got to turn it 90 degrees and flip it over and try to imagine what that screen would look like with the calculator face down. I've seen people try to do that. It's a hoot. You know, they're sitting there and they're trying to like think their way through the back of the calculator, like, what's that graph look like? You know, they're just being rebellious. That's fine, but it's still kind of funny, like doing the turn and the rotate. And okay, I'm like, oh, just get in and go parametric. It's not that big a deal. Yep.
I missed the bottom one. You decided to make it y squared minus 2y.
Oh, that was right minus left. I set it up wrong, and Coy corrected me.
Okay.
It should be right minus left. I just did it left minus right.
Okay.
All right. Any questions on that? Parametric plots, not too bad. 10 2/3 are nice. And you'll have a quiz next week. It's a 4-day week. You'll have a quiz over this section, probably on Thursday or Friday, I'm guessing. Okay, I will. How about I do that?
Yeah, Shane will actually get it.
Find the area of the region between the graphs of f and g if g is restricted to the given interval. This, coincidentally, is like Taylor's question. This question overrides any, how do I want to say it, intersections. Okay? This is a domain, so your window should only go from -1 to 2. Now, I'm not saying you want to find any intersections. Remember, if top and bottom change or left to right change, you have to rewrite the integral. So I'm going to, hey, didn't we do this one? No, we didn't. Oh, I know. Never mind. It looks familiar. I'm going to go back to function mode, function, and I'm going to put in y equals x squared first. Got to have a picture, x cubed. We did the same equations, but on a smaller window. And now my window, if x is -1, the range for g will go from -1 to 8, and the range from f will go from 1 to 4. So it looks like I need to make my window from -1 to 8. X's, the domain, -1 to 2. Y's, I'll just go from -1 to 8. That should give me the whole picture. Graph. Oh yeah, I remember we had that discrepancy about which graph is actually, well, from 0 to 0, it looks like the x squared is over the x cubed, and then the x cubed over the x squared. The bottom one's not going to be x squared. Oh, you're saying
On the positive X.
On the left side, it's gonna be.
like that? And then it's going to stop at 8? Should be? You sure? I thought we said that the... Right, the x squared's in pink, right? Yeah, that's what I got, the blue line. Oh, the other way, okay. Hey, I wonder if I can back out of that so Betsy doesn't know I made a mistake. Yeah, I can.
Still gonna hear it.
Nah, she won't listen. She'll turn the volume down. She doesn't like to hear me talk. All right. And right here we said what? Like that. Okay, good. So, on this one, -1 to 0 would be the x squared minus the x cubed graph, correct? Dx. Plus, from 0 to 1 will be the x squared minus x cubed graph, dx. And then from 1 to 2, 1 to 2 will be the x cubed minus x squared graph, right? So I can put the first two together, can't I?
Yeah.
From -1 to 1? -1 to 1, x squared minus x cubed.
So where do those go again? I know it's A matches B. And then
Right, like we have it in this case. We have the 0 and the 0. One's at the top, one's at the bottom. So we can just put the -1 to 1 together because these are the same. Okay? So, and there we go. -1 to 1 of x squared minus x cubed dx. Yeah, I think so. We're supposed to find the answer? Oh, yeah, we are. What? So, yeah, the hardest thing is making the picture. Sound the integral's not bad. Second, calculate. Quit. Second, enter. Delete. Bars. Is it? Minus bars. Function y2, comma x, comma -1 to 1. Plus math. You start to learn shortcuts pretty quick. Now on the 86, you can have the y2 and the y1 as a shortcut also. That's what makes that nice. You have to edit your, you have to go into the catalog and then put a designated button for them. Chloe, what are you doing?
Jimmy fell asleep making calculators.
Who?
Jimmy did.
He didn't fall asleep.
Yeah, he did.
No, he didn't. He wouldn't fall asleep in my class.
Hey, what else was he trying to? He's typing in on the calculator. He's back in action.
All right. Quiet, please. 25/12. So, next week on your quiz, you'll need the solution, the integral, and the picture. And if you want to add the integrals or the rectangles, you can't. I don't require you to put the rectangles, but you have to have a picture, an integral, and the bounds, all that other stuff. All right? Now, in this one, you could have set up dx or dy, doesn't matter. But we obviously went dy or dx. Questions? All right, last one. This goes with your test, the absolute value. A lot of you try to integrate and take the derivative of absolute value, and you can't because there's a cusp. FYI, when you have absolute value, the absolute value of x can be rewritten as y equals negative x from negative infinity to 0. Okay? That's the equation of that line. So y can equal x from 0 to infinity. You have to rewrite the equations. Okay? So now what we have to do is let R be the region bounded by the graph from A to B. Set up a sum of integrals not containing the absolute value that can be used to find this area. So we have to figure out where they're positive and where they're negative at from negative 3 to 4. Shouldn't be too difficult, I wouldn't think. Because to undo an absolute value, you either keep it the positive or it becomes the negative, the opposite. Okay? So this will be, I picked the absolute values because we had a little bit of problem on the test. I don't want it to show up again on the final. So, if you don't know what to do, what should you do? Graph it out. So, and then once you have a picture, you'll be in good shape. I'm going to go ahead and graph out the absolute value. Math, number, absolute value, negative x squared, negative x squared, plus 2x plus 3. My window is going to go from negative 3 to 4. I have no idea what the y values are. I'll just go from negative 10 to 10, see what happens. Then we can discuss it once we get our picture. Whoa. What happens if I take out the absolute value? Second, insert. What's the opposite? Okay, so this part right here, from what's this bound and what's this bound, you think? Negative 1 to 3 is a regular curve of negative x squared plus 2x plus 3, right? That's what that curve is. So what do you think the curve is from negative 3 to negative 1? How can you make these values become positive? Yeah, you negate them, or you take 0 minus those. They're not going to change the distance, they're just going to change where they show up. This graph will still be this far away from the x-axis, except it'll be in a positive nature. So you can take the opposite of negative x squared plus 2x plus 3 dx, or you can think of it as 0 minus that. However you want to think about it is fine. When it comes to absolute values, though, it might be better not to write 0 minus, to just think of it as the negative part of the absolute value. And the same goes for this region of the graph from 3 to 4. Again, some people might look at it as 0 minus the negative x squared plus 2x plus 3. But either way, the absolute value just makes the negative y values positive to make them go up. And then they bounce and go on. Or, as we talked about, you can do 0 minus. Okay? Now, if you want to get really fancy, where did it go? That can be used, set up a sum of integrals. Okay, so I set up a sum of integrals, got it. I want to see what happens. I've never done this before. This might backfire, but that's okay. Second, insert, math, number. Did I? I don't think so. Graph. I did? Yeah, I use the bounds given in the problem. Does anybody else have a window similar to that? Okay. I want to see if the calculator will integrate the absolute value where we can't. Math. Where did it go? Calculate. 7 from -3. I bet it can, because it doesn't read the absolute value. Look at that! How cool is that? That is cool.
Go back and come in and get
You mean to get rid of that screen?
Nailed it.
I'm just kidding, I think I went wrong.
That's fine. Maybe I typed it in wrong. -x squared plus 2x plus 3?
Oh.
You negative 23 something, the answer now.
Yeah, -23 2/3, something like that. Anyway, that's pretty cool. -23. Wait, it's going to be negative. Oh. Did mine come out positive?
Yeah.
Okay.
Go for it.
23 2/3. That's pretty cool. That can integrate absolute value where you can't. You don't have any rules for that, so you have to break it up into positive and negative pieces of the graph. Okay? Questions on that? Now, you've only got, I mean, your next test is in a month. So, but this is the key thing. This one section drives the rest of the chapter. You're going to do different things with it, but this basic idea is going to drive the rest of the chapter. Any questions? Yeah.
That answer for doing that same calculation?
Well, I don't know. That's what second calculate 7 from -3 to 4. Was it 23 or 26? I got 23. It's not really 2/3, but I call it 2/3. What'd you get?
What did you put in your graph? Did you put the absolute value?
I did. Okay.
So when you put it, I thought you took out the absolute value.
I did. I took out the absolute value. Now, this is something interesting. Ms. Bowen, why is it x squared plus 2x plus 3? Why does this graph right here, if I do second calculate 7 from -3 to 4, why doesn't it come out to be 23 2/3? Yet negative 2 1/3. Why? If you don't know the answer to that question, you need to think about it for a minute, because that's kind of a big deal before we go into next week. Why isn't that the same area? Why doesn't the same area equal 23 2/3? All I did is I took the absolute value out. What? Right, it's all positive. Below the axis is what? Negative. Above the axis is positive. So you got some positives, you got some negatives, and if you make them all positive, that's what it turns out to be. Nice. Oh, no, you won't have any absolute values. You'll have to graph those or you have to integrate those manually on your final. Okay? They won't ask for area, they'll ask for the indefinite integral. Okay? All right, good. So we got to go through 39 odd. You're on what, 27 now? Something like that?
25. What's that?
We're gonna have a quiz or a check on the page.
Probably a quiz. Page what? What page? All right, thank you. Nice talking to you, Shane. Betsy will.
Don't forget to tweet the link.
Oh, yeah, I got to tweet the link, and I got to Skype it in, too.